Okay, so this is the second lesson of exponents and exponential functions, rational exponents. So some brand new today that we get an opportunity to look at. So the learning goal is still just learning how exponents work, how to simplify algebraic expressions with integer and rational exponents. Today's success criteria 2 and 3. So we're looking at involving rational exponents and then also simplifying algebraic expressions. So question for you is, if 9 to the 0 is 1, and 9 to the 1 is 9, and 9 to the 2 is 81, which we know, what do you think 9 to the half means? What do you think 9 to the 3 half means? And so remember, like, an exponent is the number of times something occurs or something's multiplied, and it's really a counting mechanism for like exponents or for multiplication. So 9 is 9 times, or 9 squared is 9 times 9. 9 to the 1 is 9. 9 to the 0 is 1 times 9, or just no 9s by themselves. So 9 to the half actually has to be half of 9. Now certainly we don't mean 4 and a half here. We actually mean half of a 9. And so what is half of 9? So if you think of half, you're taking a number and you're breaking it into two parts. But we don't mean, again, 4 and a half plus 4 and a half. We actually, because that would be adding, that would be multiplication. If we're using exponents, we want to think about what times itself. So like half of 9 would be that there's two parts, but when we put them together, they multiply to 9. And so half of 9 is just 3. 3 halves of 9 would just be 3 of those. So 3 times 3, sorry. So 9. So then we've got 9 to the 1 half equals 3. 3 halves of 9 is just 3 of those. So 3 times 3 times 3, or 9 times 3, which is 1 and a half. But we're thinking in terms of halves, and so that extra 3 there would be the other half. So 9 to the 3 halves would be 3 times 3 times 3, which is 27. Which is actually right in the middle, multiplication-wise, of 9 and 81, because if you multiply 9 by 3, you get 27. 27 by 3, you get 81. So a couple questions you can do. You can try on your own. Certainly, you can pause it. 27 to the 1/3 is a third of 27, so break up 27 into a third. And so 27 into a third is 3 times 3 times 3. That's the 3 parts that give you 27, and 1/3 is just 3. So 1/3 of 27 is 3 cubed, and we also can write this as the cubed root of 27, which is 3. 625 into 4 parts would be 5 times 5 times 5 times 5. If we just wanted one of those, it would just be 5. So a quarter of 625 is 5. We can also say 4th root of 625 is 5. 8 breaking up into 3 parts is 2 times 2 times 2, and if we wanted to take 2 of those, we would do 2 times 2, which is 4. And so 2/3 of 8 is 4 with respect to exponents, and we can also say the cubed root of 8 is 2, and then squared that is 4. And so we can say, we get a method for how to actually break up exponents with fractions, and it's the cubed root of 8 squared, which is 4. So 32, 3 to the 3/5. 32 broken up into 5 parts is 2's, and we take 3 of those, we get 2 times 2 times 2. So the 5th root of 32, that gives you the 2, and then 2 cubed, which is 8. 81, we can deal with the negative exponent first. We could say that's 1 over 81 to the 1 half. We're not flipping the exponent, so what that does is we slide the 81 to the 1 half down, and the negative 1 half becomes positive. Then we break up the 81 into 2 parts, and one of those parts is 9. Similarly, now this is the first one we've seen with a negative. The negative 125 into 3 parts is negative 5 times negative 5 times negative 5. So that negative is part of it, and we just want one of those negative 5's. So the answer is negative 5. So the cubed root of negative 125 is negative 5. So in general, we can also consider just like looking at the exponent 1/2 and realize that it is the same as doing square roots with radicals. 1/3 is the same as doing cubed roots. So like the exponent laws say half plus a half is a whole, so this is 3 to the 1. The square root of 3 times the square root of 3 is the square root of 9, which is also 3. And so you notice that like 1/2 and square root are the exact same thing. And just in general, the fraction is like that number of root. And so if we have 1 over n, x to the 1 over n, that's the nth root. And that's something that will actually come up again in finance when we need to solve for interest rates and we have big exponents. An algebra question here is now similar to the last lesson. We just break up each part. We can look at the cubed root symbol and move it to a fraction. You don't have to. You can think about each cubed root of each part. So breaking up each part into 3's. Similarly, for the bottom, you can think about each part into halves. But we can also write this. I like to write it with, I'm sorry for the cloudiness there, but each of these parts is to the 1/3 or to the 1/2. So 27 to the 1/3 first is the cubed root of 27, or a third of 27, which is 3. A to the -3, we can actually use our exponent law, -3 divided by 3. 12 times 1/3, which is 12 divided by 3. Half of 16. A to the -8, half of that. Which, I mean, you can also think of it as a to the -8 is like a to the -1 times a to the -1. And if we wanted half of those, we got a to the -4. It's easier to see with positive exponents. B to the 12 is b to the 6 because it's half of them, which is b to the 6. Okay, and that does work straight up as half, unlike the 16, because that's all multiplication. That's all broken up into factors. That's what exponents are. And then we can do the slide the a to the 4 up and the a to the -1 down. Notice that the b to the 4, b to the 6, the 3 and the 4, they don't change, just the a to the 4 and the a to the 1. And now we can simplify. So the a cancels out with a to the 4, the b to the 4 cancels out with b to the 6, and we end up with 3a cubed over b squared, over 4b squared. Okay? So one like this, there's a couple of choices you can do here. What you can't do, I should note, is that you can't slide the negative exponents until they're like out of that bracket. So they need to be raised to the 1/3 first. They can't just slide down until they're out of the bracket. So in a question like this, we have to do the brackets first, and then we can actually evaluate it. So it's up to you. If you want to do 4 to the 4, I just probably wouldn't put the number down for 4 to the 4. I would leave it because I see this -1/2 has got to come in anyway. Or you can bring the -1/2 into the 4 and the 6. You don't bring it into the 4, the x cubed, and the 4, because by hitting the 4, you've already hit the whole top, because that 4 is going to come into the 4 and the x cubed. And then the 6 can be brought into the -1/2. And that's exactly what we're going to do. So we multiply 4 by -1/2 and we get -2. 6 by -1/2, we get -3. Now we can actually slide it because we got two negative exponents. So if we want to take care of the negative exponents right away, we can just slide these up and down. But this is a little bit tricky because nothing else changes except those 3's and the 2's. The x cubed, you can imagine it as x to the -9. It becomes x to the +9 on top. So we wouldn't change this x cubed to a -3 when it slides up because it's already changing with this -3. That -3 applies to the whole bracket. So by changing that sign, we change the whole thing, and that's a little bit confusing. But you can look at like doing that a couple ways and making sure that you kind of wrap your head around that. So take some time to think about that. But now the nice thing is we don't have any more negative exponents. So we've got x to the 9 on top, 16x to the 6 on the bottom. Remember that 4 has to hit the 2 as well. X cubed to the 6. Now we can reduce the x to the 9 and x to the 6 as x cubed over 16. And there's some